We're going to find the volume of the solid formed by revolving that shape, I've already highlighted it, around the x-axis. And that is the shape that's bounded by the graph of f of x, which is 3 minus x squared, and g of x, which is equal to 2. And take that, rotate it around, and as we do, we are going to go from, here we go, -1 to +1. That's what we're going to be dealing with. -1 to +1 because we're on the x-axis. And we're always going to do outer minus inner. Okay, so in a previous lesson, we had done something similar, and it's not really that different yet, but it's going to be in a minute because we're going to revolve it around other lines other than the x-axis, and things are going to get kind of crazy. So I do need to keep in mind what the outer function is and what the inner function is. So here we go, this is pencil time. This is the x-axis. I mean, no one's surprised at that statement. But with the shape that we have right here, the outer radius is the parabola, and that comes first. So if I just said, find the volume that you would make if you rotated this shape right here around the x-axis, you would say, well, that sounds circular to me, so it would be pi, and then the f function squared, blah, 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 dx. And you'd be right. However, we're not just going to have some shape with some outer radius that's done this. We've actually cut a hole in the middle of it, and that hole we're going to subtract away, and that is the g function, and it is squared. And this is it right here. It's really that simple, but we're rotating around the x-axis. Well, now let's not rotate around the x-axis. Let's rotate around, and by the way, I'm not too concerned about the actual answers. We'll play that game in a minute. Let's rotate around the line y equals 1, okay? Well, if I rotated around the line y equals 1, then I'm up here. Here's the line y equals 1. This is the way I used to explain it, and I'll use it this way a little bit. This is my new x-axis. Now, it's not the x-axis, but if I wanted, if, you have to say it 5 times. If I wanted to rotate around this, then I would have to redefine my functions based on this as my new x-axis. So again, rotating, which creates a circular shape. We're still going from -1 to 1, regardless of what axis we're dealing with that is horizontal, -1 to +1. And then, instead of saying, well, it's 3 minus x squared, no, it's not anymore. Because if this is my axis of revolution, then my axis of revolution is the defining baseline for my functions. So I'm not up 3 from the origin, I'm up 2 from the origin. Okay, I mean, now here's the origin, it's still the origin, that doesn't change. But I hope you notice the way that we've just gone from, hey, look, it was up 3, oh wait, no, now I'm rotating around this, so now it's up 2. So this is no longer 3 minus x squared, it's 2 minus x squared, okay? I hope you see the similarities here. So this is f, which is 3 minus x squared. Let's write this again, just because we probably should for explanatory purposes. 3 minus x squared, minus 2 squared. Let's parenthesize just because I like to overdo it. There we go, there's that. All right, minus. Okay, we're going to subtract away the inner function. Inner function, what are you talking about? From our axis of rotation, from our new axis of rotation, which is y equals 1, from this line, the outer function is the parabola, still. The inner function is the line, and the inner function is 1 unit up, not 2 units up. So it's minus 1 squared. Okay, I've over parenthesized again, but that's the idea. All right? Now, there are other explanations that are out there in different software programs, different videos you can watch, where they would not do what I just did. They would not say, oh, this is f minus 1. They would say it's 1 minus f. Okay, let me rephrase that. So what I really got was 3 minus x squared, and then I subtracted 1. I really got 2 minus x squared. That's where this came from. There are those that would go about this differently. Let's make it look the way it should look. There are those that explain it differently, and they would say, oh, well, it's really 1 minus f, and they would square that. They're not wrong. I'm not wrong. I just find it easier to explain from the perception of a translation. Okay, let's erase this axis of rotation and try this again. Now we're going to rotate around the line y equals 4. Okay, so here's the line y equals 4. And we're going to rotate around this line. That looks like the letter G. It's not. It's an arrow that goes around in a circle. We're rotating. We're going to take this shape and it's going to rotate. So as we do, rotating creates a circular shape. -1 to 1, -1 to 1 still. That's the shape of this highlighted piece. And we are going to rotate outer function minus inner function. What's the outer function? Well, from my axis of rotation, the outermost function is not the parabola anymore, it's the line. And this line is now, from where we are defining it, technically -2, not +2, okay? Now, when you square it, it's not going to make a big deal, but just for the sake of argument and accuracy in the setup, technically this is -2. And then we're going to subtract away the inner function. And the inner function is this parabola. Well, what is the parabola? Now, I know the parabola is 3 minus x squared. Let me erase my other stuff from the previous axis of rotation. Thanks for letting me do that. There we go. It's 10 seconds of your life you'll never get back. Aren't you glad you watched that? So what I want to do now is define this parabola based on my new axis of rotation, like as if this was the x-axis, and it's not. But if it was, then this parabola would not be 3 minus x squared. It would be -1 minus x squared. Okay, fair enough. And this is the setup for each of them. So just for the sake of actually having an answer, because that's what we need to do, they did tell us to find the volume. Let's do this. And we're going to kind of process through this as we go. Let's go ahead and set up f and g. I'm going to take some other stuff out that I had done previously. 3 minus x squared and 2, so there's that. And the first one is kind of straightforward, so it's going to be pi, math 9, -1 to 1. Ooh, by the way. Now we'll do it in a minute. I was about to get all excited and decided not to. Ooh, let me show you something later. There's that, okay? 20. I'm curious, if I didn't multiply by pi, would it be a nice, prettier number? Let's find out. Let's do it this way. Let's divide by pi, I'm just curious. Ooh, 6.4. Okay, final answer is 6.4 pi. Good to know, good to know. All right, I'm gonna write that. 6.4 pi, 6.4 pi. Interesting how that worked out like that. So that is 6.4 pi. Let me show you that cool thing I was thinking of just a minute ago. So this was what I typed in to get the answer, 6.4 pi. However, I hope you also notice the symmetry. This is beautiful. This symmetry means that I really don't have to compute all the way from -1 to 1. I could compute from 0 to 1 and then just double it. So let's do the same thing. I'm going to insert a 2 here. You don't have to type it. You can just watch. And there we go. I'll get the same thing. I better, and I did. Ah, lovely. Okay, let's move on to the next problem, which I could type it in the way it looks here. However, I'm not going to. I'm going to put a pi. I'm going to do math 9, -1 to 1, and we can do the double and halving thing. Half the interval, double the volume in this case. And we are going to do, and this is beautiful, I'm going to do f minus 1. This is my f function. I'm going to subtract 1, and then I'm going to square that. Now, again, other people explain it as 1 minus f based on the way they articulate things, but basically I did have 3 minus x squared, and I really want it to be, and just going back to this one, 2 minus x squared, so I'm subtracting 1. And then minus, and that's 1 squared if you want to get all technical about it. That was the g function, subtracting 1 from it as well. So that's really just 2 minus 1 and then squared. There's a lot of unnecessary 1s in there. You could just call that minus 1, but there's your answer. All right. Oh, by the way, I'm just curious. Let's divide that by pi. Oh, oops, not that many times. 7.3 repeating, I'm curious. I'm just having fun right now. Nope. That does turn into a fraction. I know it has to. In the meantime, let's just do the decimal. 11,729. No pi on that. And then we'll do this one. This is where things get a little bit wacky. So pi, math 9, -1 to 1, and then parentheses. Okay, this -2 was really the +2, but we are shifting, our line shifted up 4, so we have to subtract 4 to compensate for it. So it was the g function and then -4, and we'd square that. And then minus the f function and then -4, and we'd square that. And I'm double checking. Yeah, and again, other people explain it differently. They'll do 4 minus y or 4 minus y2. They'll do that. Same thing. It works the same. 13.404. There we go. Just scrolling to make sure I didn't. Yep, no typos there. All right, we're good. Hope so.